Hey guys, how's it going? Welcome back to the part 3 of object-oriented programming present in Python. In the last couple of videos, we have talked about how to define a class and an instance under that class. And also we have talked about the initializer and the destructor, how you can define it under a class. And in the last video, we have talked about the difference between instance method and attribute to the class variable or attributes and method. And in this tutorial, we're going to talk about a very important concept in object-oriented programming, that is inheritance. And before we dive into that topic, I forgot to mention the static method in the last video, but nevertheless, we're going to cover that one in this video first. Then we will jump into the inheritance. To recap, what is instance method? Instance method takes instance as a first argument, and by convention, we use the keyword self as a placeholder for that one. Similarly, the class method, we use a class method at decorator first, then we define the class method. And in the class method, class is the first argument, which we use CLS as a convention as a placeholder for that class. And in the static method, it's like a general or normal function, but it exists within the class and it doesn't take class or an instance as an argument for that function. Now, if this method or this function doesn't take any argument, which is neither a class or an instance, why it even present within the class? Now, there are many reasons why you need to keep a static method for that one, but the primary reason is reason behind it. There are some kind of significance relevance of that method to be present within the class. We're gonna see example in a minute, but there are other reasons as well. Now, in the future video, we're gonna see how you can, once you define a class, it's like a package, and you can import this package in the another program. And if you have defined all the function and static function, class function as well as instance function, you just have to import once, that is the class only, and rest of the things like all the functionality that present within the class will available uh, in the other programming where you have imported this class. Now, don't worry, it's a bit of complicated situation right now because we haven't talked about the import functionality yet, but let's keep that in for the future video. But in the for as of now, you can think of that we generally use static methods under a class because it has some significance relevance for that class. Okay, similar to the class method decorator, we also use a decorator to define a static method. And for this one, we use a decorator called static method. Static method. Okay. And if I haven't told you what is this decorator, it's mean that in a normal way, normal course of action, this is a function that is available for the instance. But the using of this decorator, it's changed the way of this function. So basically, this decorator changed the functionality, even though syntax is the same. Okay. Now, for the static method, we can also use this function, keyword def stands for definition, which is generally we use for define a function. Then we can say leap year, leap year, and this method will take year as an argument, and this is neither an instance or a class. And what it's gonna do, it's gonna return if that year is a leap year or not. Now, this particular function is neither a class or instance specific method or function, but it has some significance to this class employee, because if the year is a leap year, then probably the employee has to work 1 day additional as compared to the rest of the years. So probably there might be some correction in the employee factor or a company factor for the leap year. I don't know, just an example, huh? So Because this has a significance relevance to this class employee, so we are using this method under this class, and this is a static method because it doesn't take class nor an instance as an um, argument for that function. So here what it can do, it will test first if that here with the modulus division by 4 is equal to 0. If this is true, then it will say return it is a leap year, and else it will return it is it is not a leap year. Okay, now let me delete everything till here, and let me first run it. Now it is run. Now if I will so now this particular function, this particular method, static method, is available both for is available for the class employee. That means it is also going to available for the instance. So we can access this method by using employee, which is the class name, employee, and when I use this dot operator, you can see there is a method leap year. So I can use that one and pass 2018, which is the year, and I'm passing this on as an argument, and here I can say print. Now if I will just go ahead and run it, you can see it is not a leap year. And we can also access this same um, leap year functionality, leap year static method from the instance also. So if now emp1 is an instance, and we can also use this function, the static method, using this instance emp1. Now if I will save it and run it, now let me change it to 16. So in that way we can see the difference. Okay, 16 is a leap year, but 18 is not a leap year. And we can access this leap year functionality, which is a static method, both by using class as well as the instance that defined under that class. Okay, that should be enough for static method. And this is very generic question, interview question that you often get. What is the difference between class and static method? And with all this example and the theory which we have talked about, it is hopefully it is a bit clear now. And if you have any question, as usual, you can post your comment in the comment section. But let's just keep moving and discuss about this concept called inheritance. Now, in general, generally, when you define a class, you use the keyword class, then the class name, then the colon. But and in this is the class which we have defined is a standalone class. That means it doesn't have a parent or a child class. But a class could also be a parent and also could be a child. To give you an example, technical employee. Technical employee. If this is a class, let's pretend this is a class. This technical employee is the kind of employee who has some technical skill set like Python, C++, Java, and whatnot. And those technical people also a class employee because they also work in that organization. So in that way, this is the child class from the parent class employee. Now to define this is the child class of the class employee, you can use the keyword class as usual. Class, then the name of this class, and to inherit from some other class, some parent class, use that class name in the bracket, in the open and close bracket. So here I can use employee, and this will, and then use the colon. Now as of now, just use the keyword pass. So in that way, I'm just will show you. Here we are not defining any function or any attributes, but as this technical employee is inheriting from the employee, all the functionality that present under this class employee will also going to available for the technical employee as well. So now if I will just change this one, delete this one, and here I can say instead of employee I can say tech emp, and let me change it emp1 to emp, and here I can say technical employee to technical. So now here what I'm saying, employee is a class, is an instance of a class employee, and tech employee is an instance of the class technical employee. Okay, but technical employee doesn't take any we haven't defined anything, even the init function, init method as of now. But as this function, this class technical employee inheriting from the employee, all this thing, all this init method, email, and so forth, so on and so forth, also available for technical employee. So we need not to specify everything again here. So to prove my point, I can use this tech instance and apply this method email, you know, the method that is defined for the class employee. And then if I will just use tech.emp email id and print it, print, it should not give me an error, and it should print the email ID for the technical employee. Now let's just go ahead and run it. You can see Vijay underscore Sharma at the rate of gmail.com, and this Vijay Sharma is an instance of the class technical employee, and as this technical employee is inheriting from the employee, that is why all this method and attribute is also available for this instance techemp. Now let's talk about two of the inbuilt function that define under this Python, with which you can identify an instance of a class and also a class of subclass of a class. The first one which we're going to talk about is called isinstance, and this built-in function will take two arguments, the object. So here I can say, take emp, and if this particular instance is a is a is a is a part of class technical employee or not. If you just now let me print it, or else we cannot see anything. Now just go ahead and run it. You can see it is true. Okay, let me comment this one out. And if I will change it from technical employee to employee only, it will show you what oh, it's also, so it will also show true, because technical employee is also an instance of employee, because it technical employee is inherit from the class employee. Okay, similarly you can say, we can discuss about another built-in function, which is subclass, and this built-in function also gonna take two arguments. The first one is the class name, and here I can say technical employee, and the second one is the one that it inherit from. So here I can say it's employee. So if technical employee is a subclass of the class employee, it will return true, or it will false. So here you can see it is returning true. So this is how you can see instance a part of the class or not. And also here with this built-in function you can test whether this is a subclass of a class or not. And before we move to the extension of a method, of a parent method, let me give you another thing. And here I can say print, and we have already discussed this built-in function help. And if we say oops, and if I will just pass this argument, technical employee, and let me comment everything till here, save it and run it. Sorry, let me save it and run it. And here you can see uh, you can find an information about technical employee, and here it is saying it is inheriting from the class employee, and by inheriting it has all the function all this method and attributes. You can see even this class method and the class attributes is also available for this child class. Okay, now let me first delete everything till here. And now let's say instead of pass, I can use, this class method employee.factor. And as these people are technical people, the raise amount, the factor in which they got raised should be different from the normal employee because they are technical, they are hardcore or whatnot. Okay. Anyway, so let me put a factor 2 here. Whatever the amount, whatever the factor the general employee get, technical employee get twice. So if now, as of now, let me change this one to 50,000, and both emp and tech emp, they both started with the same monthly pay. Now if I will just raise print and he say emp dot um, month pay, and I can say print word. Let me copy this one and paste it here. Sometimes it's so hard to write, tech emp, and here you can say month pay. And now I can say emp dot raise amount. I'm applying this method raise amount on the instance emp, and I will also gonna apply the raise amount to the technical employee as well. And if I will paste the value of the monthly pay for both emp and temp emp, and if I will just go ahead and run it, you can see, let me maximize this window. Here you can say they both have started with a 50,000, but as the emp is a is an instance of class employee, it will get only 1.5 into one time, that is 1.5 time as a raise. So that's why it's getting 75,000 for emp. For technical employee, as this factor is 1.5, but emp factor is 2, so 2 into 1.5 is 3. So in the next cycle, the technical employee will get 3 times, which is 50 into 3 is 150k. And that's what we are seeing after the application of the raise. Okay, now let's say this technical employee, as they are the technical people, they must know a language, a programming language. But general employee, those who are not technical, this thing is not should not be mandatory. So here in the init function, I cannot pass the programming language an additional argument. So if I will say, a programming language, let's say Python, it will throw me an error because Python is is an additional argument we are passing. And if we want to do such thing, we need to extend this init method. To do so, here I can say div init, same thing as what we have done so far. Let me copy this thing only and paste it here. But here in the end, I can pass another attribute, programming or proglang. So now this particular instance defined under this technical employee will take an additional argument, programming language. So this is all valid, but somehow we need to extend this method, this init method of the class employee to this to get the additional argument, programming language. One way or generally you get intent to do is that you will just copy everything till here and paste it here, and then you can say, self dot, let me copy this one, prog lang equal to prog lang. But this is not efficient, So instead of doing this one, it's very tempting, but don't do it. It's not a standard way. People will laugh at you. There's two ways you can do it. You can use super, and let me write it down first, then I will explain you what it does. Init, mm, sorry, then I can say from this one to month pay. Okay. By doing this, we are saying super. So this is the child class. Whoever is the parent class, take that one's int class, init method, and and use this argument: first name, last name, and month pay. And the next line we are using programming language, which is the extension of the init method, the class init method, employee init method. So if I will just go ahead and run it, what I can do, I can delete everything till here, and instead of employee emp, we will say tech employee, and here I can say prog lang. If I will just go ahead and run it, you can see it is showing Python, because tech employee has an argument, has an attribute called proglang. Another way to do it, you can use literally the name of the class, and here it's the class name is employee, which is the parent class. Oops, employee. Then I can say the same thing. Let me copy everything from here till end and paste it here. But here you need to pass this argument, this instance argument self as a first argument to that init method, because here you are accessing this init method of the class employee. That's why you need to use this keyword self as first, then use the rest of the keywords that the init method takes. Now both are valid function. Now if I will just go ahead and comment this thing, the first thing, it will still work fine, but there is some issue with this, the second way of doing it. So I would not suggest you to recommend this thing to do it. When you inherit multiple parent class, then this will create a problem. Super will still work fine in that case. Let's close the object-oriented programming in Python as of now. Essentially, you can do many things, and we have just scratched the surface of it. If you have any questions so far, please drop your comment or question in the comment section. Or else, as usual, thanks for watching. Thanks for all your likes and subscription. Until next time, cheers.